or you are currently working with someone in cloud. Okay. May I know first, any of you who are currently working in cloud? Raise of hand. I think there is a gesture whereby you can just raise your hand. I'm not sure where it is, but supposed to be there. React, I think. Yeah. Uh, recognize gesture, something like that. No, it's not like that. Okay, a raise of hand. If anyone, none. Okay. Uh, okay. I don't know your background, so can you please are you all students or any of you are working? Most of you are working. Working. Okay. Okay, most of you are working. Thank you. That's good. Are you working in? Okay. Fatun is have something in cloud, I think. Okay, that's good. Someone in cloud background. In IT, all of you are in IT. Yes. Okay, good. Okay, the thing is because there will be some terminologies that I will be using. Of course, I will try my best to explain them. Um, but it is going to be quite hard if, let's say, you don't really have any IT background. I'm not saying that it's going to be that hard because the concepts are there. Only need to understand the concept. It's not that you need to understand everything, but the concept needs to be understood. You need to understand it. Okay, so as stated there, the tracking candidate should have the knowledge in the following areas: the concept, security, compliance, da 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 da. Okay, this one here is also something that I need to emphasize on. Job stakes that are out of scope for this target audience. When you are doing the AWS, you will not be asked to do any coding. This is just for the certification. Okay, join class after picture. Okay, fine. There's nothing there. All right. The things that you will not need to do for the exam, you don't need to do any coding. There will be no coding at all. Okay, unlike certain certification like Kubernetes, whereby you are required to do the exam, to do the coding during the exam, this one is just none of those. Okay, so you can just relax. You just architecture design, you will not be asked to design, you will not asked to do any troubleshooting. If, let's say, they're giving you a system and the system is not working, okay, go and troubleshoot what is the problem. No, you will not be asked to do that. You are not asked to implement anything on the AWS, and then also the performance testing. No testing, no implementation, no coding, no design. Okay, very simple. This is a foundation exam. It is the first part of AWS certification. Okay, exam content. There will be two types of questions in the exam. Everything will be multiple choice. Answers will be given to you. You just need to pick which one that you feel your gut says that is correct. It doesn't have to be your brain says it's correct, but your gut says it's correct. It's okay already. All right. So it will be a multiple choice, A, B, C, and D. And also some of them will be multiple responses, meaning you have to choose 1 and 2 is correct, or A and B is correct, or A and C is correct, or 3 of them is correct. Out of 4, 1 of them, 3 of them are correct, something like that. But whenever it is required for you to do this, they will tell you, answer more than one, also choose more than one, certain things like that. So you shouldn't be worried about not knowing the answer, because the answers are there. It's just you have to pick the right one. Unlike some questions, subjective questions, answers will not be there. You have to think about it, and then and then you have to make up something to answer it. This one you don't need to make up anything. The answers are there. Just need to be sure which one to pick. That's about it. All right. The other thing, the interesting thing about this particular exam is, okay, let me go through the number of questions first. You will be given Where is it? Is it stays there? Okay, select one or more responses and that best complete the statement or answers the question. Distractor or incorrect answers are response options that the candidate with incomplete knowledge of might choose. Okay, so this one are the wrong answers lah. Don't go and do that. Distractors are generally possible responses that match the content area. It is something that is similar to the answers but not correct. Okay, unanswered questions are scored as incorrect. So don't leave any question unanswered. Everything should be answered. Okay, there are no penalty in guessing. The exam includes 50 questions that, okay, here is the thing. The exam includes 50 questions that affects your score. Okay, it says here, remember this, the exam includes 50 questions that affects your score, but not the total number of questions. Okay, unscored content. The exam includes 15 unscored questions that do not affect your score. So here they say the exam includes 50 that affect your score, and they have 15 unscored questions that do not affect your score. What it means here is that you will be facing 65 questions. Okay, get it? You will have 65 questions. Out of that 65 questions, 15 of them are questions that will not be scored. Suka-suka je dia bagi. It will not be scored. You are given you will not know which 15. In that 65, you will not know which 15s. It will not just have an asterisk there or anything like that. You will not know. Okay, those 15 will not be scored. The 50 will be scored. Okay, understand on that part, huh? Everybody good on that? Okay, all right. So 65, 50 will be scored. Okay, the result. Okay, here, result, exam result. The certified questionnaire exam has a pass or fail designation. So if let's say you get full mark or you get atas pagar, people will not care. Because they will show you either pass or fail. That's it. Understand, huh? Okay. The exam scores against a minimum standard course established, blah, 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 blah. The result of the exam are reported as a scale score of 100 to 1000. I don't know why they make it 100 to 1000. They don't make it like normal 100. It's just how they do it. It's 100 to 1000. Full mark, meaning all 50 questions correct, will get 1000. One question is what? 20? Isn't it? 50. 20 times 50, right? Something like that. Okay, because, yeah. The minimum passing score is 700. 35 questions, I think. Correct? 70, 35 divided by 2, yes. 35 questions. So you are allowed to have 15 questions wrong. Banyak kan? 15, quite a lot of a number. So it shouldn't be that hard for you to pass this exam. Okay. But of course, that 15 plus the 15 that is not scored. So the maximum number that you cannot, that you can have wrong is 30 questions, provided that you are not answering those those 15s are the unscored one. Okay, provided the other 15 is the unscored one. Okay, then how do you perform the exam as a whole, whether you pass or score? Okay. Content outline. Okay, so this one is what we'll be learning. We'll be learning for this 4 domain, which is the cloud concept, the security, the technology, and also the billing, pricing, and support. You will see why this one is inside the things that you need to learn. Okay, the amount of question will be, this is 25%, this is 30%, this is 34%, this is 12%. Previously, I think about 2 years back, the percentage was different. I can't remember what it is, but this is the new one. Okay. Okay, cloud concept. Okay, so these are the things that we'll be learning. in the cloud concept, the value of blah, 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 blah. You can see here quite a number of them. Security and compliance, these also will be going through. And then understanding the governance, management capability, skills, technology and services. Okay, this one. The cloud technology and services, different ways of provisioning, and then the services, where was it? Defining global infrastructure, compute services. Okay, this one. AWS, knowledge of AWS compute services, recognize, and then storage. Okay. Okay, this one, services from scope, service category, choosing okay, fine, billing and pricing. Okay, so you can go through it. I already shared this one, and this is here in your classroom, exam guide. Okay, so certification path. Okay, since we are taking the CCP, which is the fundamental, the foundation. Okay, I'll just show you this one first. Just give it a minute. Yeah, there you go. All right. So this is, if let's say you are planning to be a professional AWS cloud architect or something, or AI, this will be the certification that you may require to take. So yours will be here. This is the beginner's one. All the black color one will be the beginners. Okay, so if let's say you want to go for solution architect or application architects, this will be the roadmap for your certification. You don't have to, but it is suggested that you do this so that you'll be a certified AWS practitioner. Okay, so data analysis, developments, operations, test engineers, cloud developments. So you have most of the career path if let's say you are interested in doing this. Okay, so I provided this one as well, just in case. All right, so that's done. We can go to our module. This will be our first module, which is the introduction to Amazon Web Services. In this, the objective for this particular module will be to summarize the benefit of AWS, describe the differences between the on-demand delivery and also the cloud deployments, summarize the pay-as-you-go pricing model. There'll be some models. Oh, before that, let's do this first. Okay, how I conduct the class will be, we start at 9. We did start at 9, right? Okay, we start at 9 and we will finish at 5. Okay, in between, normally I will have about 1 hour and a half of talking, and then we'll take a 5-minute breaks or 10-minute breaks, depending on the situation. Okay, during those breaks, you can just go and get some vape oxygen ke, apa ke, depending. All right, so it will be 1.5 hours of listening to me, and then 10-minute breaks, and then start again. We'll stop at 1 for lunch, and then we'll start again at 2. Continue on until 3:30, another break, and then up until 10 minutes, and then so on, another 1.5 hours. And at the end of the day, we will do one test. Okay, every time we finish a module, there will be a quiz. Okay, that's how we will conduct the class. All right, understand? Any problem? Any? Okay, good. Okay. Ingatkan ada orang macam, no, don't want any quiz. Okay, anyway. Okay, let's go through our module number 1. You can download this. It's available for you already. I don't need 2 because I have 1 already with me. Here, this one. Okay, this is the AWS Cloud Practitioner. Okay, let's go through. Do I need to do that first? No, I don't need that. Okay, let's go through this one first. Okay, this is to build your AWS Cloud knowledge through, well, it says 11 modules. It is 11 modules, but the first module, the 11th module, is actually regarding the exam, what we went through just now. It is one whole module, but we're going to skip that one. We're going to do 10 modules only, covering concept, security, services, architecture, pricing, and support. Okay, those are the things. Okay, cost structure, I don't think so you have this. I think you have here, module number 1. Okay, sorry, my mistake. Okay, module number 1, learning objectives, summarize the key advantage of AWS, the delivery model compared to on-demand and cloud developments and pricing model. Okay, so this is, okay, first of all, we'll talk about the services, the cloud. Okay, in a sense, what cloud is you are trying to retrieve information from a source or from a place which is normally resides in a server in the internet itself. Okay, what do we normally do is that we open our PC, go to the browser, go to Google, go to DuckDuckDuck, or say we go to any search engine, or you can go to ChatGPT or whatever. It is still the cloud. You type in something, and what you expect is that it will give you some information. So what that is that you are here. We are the client. It can be a PC. It can be a phone. Nowadays, a phone is also like a PC already. So it can be a phone. It can be any electronic devices that interact with the internet to obtain some information, some data. That data can be resides in anywhere in the world. Okay, but in normal cases, it is residing in a server, and then the server can be like Amazon EC2 fulfilling. These are all, we will not may not understand it yet, but it is something that we will go through later on. EC2 fulfilling the request, web browser application making requests. Like I said, it can be a web browser, it can be any application. And this is not just specific to the internet. It can also be something that non-internet related at all. As an example, if you are in your office, you open up your office application, for example. Good example is SAP. Anyone here knows what SAP is? Anyone have done SAP? Oh yeah, good. Okay, Najmi is there. Okay, SAP is not really something, it is, okay, what SAP is, let me explain first. SAP is a system whereby people normally buys it for, there's a lot of module in SAP. You have inventory, you have costing, you have quite a number of them. So, and that one normally does not reside on the internet. It resides on a local server at your office. Normally, but it doesn't have to. Again, it doesn't have to. But in normal cases, some cases, it resides in your local data center or in your local server. So you don't go through the internet at all, but you go through your intranet, your local LAN. That is also considered as a client to server model, whereby you are requesting something from the server, or you are requesting something from a machine that is not residing, that's not your local machine. Then the information or the data is not on, it's not stored locally. It's not stored on your phone. It's not stored on your PC. It is stored on another PC. But what you need to do is you need to use an application to obtain and to grab that data. Okay, so that is also a simple example of a client server model. It doesn't have to be, internet doesn't have to be included there. Okay, it can. Most cases, yes, but doesn't have to. All right. So that is the client server model. Okay, we done this one. Let's go down. Okay, cloud computing deployment model. Okay, first of all, what is cloud computing? Any ideas? You can chat. You can type your answers in the chat, or you can speak out if you want. But what do you think? What is cloud computing?
May I answer?
Yeah, go ahead. It's a free country. Go ahead.
So from what I understand, cloud computing just means that you deploy whatever you are doing. Let's say you are developing an app, so you deploy the the app onto a cloud-based resource. So means that it's a remote source lah.
Okay.
That's
Okay.
how I understand it.
Okay. That's okay. That's good. Okay. Borrow someone else's computer for service. Okay. You borrow, you go what next door? Non-physical infrastructure. Okay. Um. So to say, okay, fine. It's not in local. Okay. Can. Okay, cloud computing. Oh, I think they have one video about this. Let me just see. I think they should have it. I know. I remember. I shared it last time. AWS. Okay. AWS. Cloud computing. Okay. Should be here. Yeah. Have it here. Okay. Fine. Says. Okay. Here. What is cloud computing? Okay. This one. Okay, cloud computing is the on-demand delivery of IT resources over the internet with a pay-as-you-go pricing. This is, okay, this one is actually AWS definition of cloud computing. Okay, but in general, it is something that you are getting, which is some, as mentioned before, it is something that you are it is a service, or it is not say service, it's a computing power that you use that which is not belong to you. It is somewhere else. Okay, that's in general. Okay, instead of buying, owning, Okay, who is using cloud computing? There's a lot of people using cloud computing here. It's not here anymore. Let me just get it. I think I should have it here.
Video tu dalam essential cost rasanya.
Yes. That's the one.
Kena masuk essential cost tu.
Dekat essential cost, eh?
Dia tak boleh.
I thought it was here. Oh, so you've seen the video already?
Dalam essential cost tu memang ada video dia. Sebab
Oh,
dia
yeah.
bagi. But some of us kena tengok video baru faham.
Oh,
Macam I just go
okay.
like baca.
Sama.
Okay.
Me also. Have to see video. Okay, can you share me the link again? Kejap, I have to go and look for it. Cloud Essential, where was it? Did I close it already? Okay, yeah. I think I can just find it here. Cloud computing. What is cloud computing? I think this one. Is it? No, this is the one that we went to just now. Just go to video. Was it here? No, that's not the one.
You kena search apa? AWS Builder.
AWS Builder. No. Okay. No.
Sikit.
Is
Ini
it this one?
YouTube ni. Like, ini yang kat YouTube.
Oh, is it? Yeah. Let me see. Not this one. Wait. I need to share the sound with you guys. This is not the one, but it's okay. We'll just have a look at this one first. Where do I share the? Shoot. Okay. Can you hear this the sound or not? If not, I'll have to share the sound. I can't remember. No, huh? Okay, just a minute. Is it okay? Still so slow.
Tak ada sound.
Tak ada sound, huh? Let me just find where is the share sound. Share, advanced sharing. thought it was supposed to be here. This was skill builder. Let me just have a look here. Okay, so that's from skill builder. Let me just see. Was it here or not? A review of. Okay, so all right, let me just go here first. I'll show you this. This is the skill builder. This is the what is AWS. Okay, we'll go through a few of them first. That you so that you will like some of you said, you need to look at the video first to understand what it is. So we'll look at what is AWS, and then we'll go into okay, I'll copy the link just in case if you need it. I'll put it in the in our, and like I said, we will use our classroom. So I'll just put it here. This is AWS. Okay, so this is what is AWS. Okay, let me just play this one. How do I go? Okay, this one. Okay. Okay. That one is most of it is what you will be learning. They said something about pay as you use. They said about high availability. They're talking about region. They're talking about availability zones. Most of it is the things are things that we'll be covering. Okay, okay, I found the one. Okay, just let me just copy that one here. I already given you this one, right? Did I give you this one? Yeah, let me just copy it again. I can't remember. Um, this is the introduction to AWS. Okay, so this is the introduction to AWS just now. This one is for which one? Huh? Let me just see. Oh, it's the same one. Oh, it's the same one. Okay, fine. So I can just delete this. It's the same one as on the top. Delete this. Okay, so the other one that I want to show you is, where was it just now? Ah, hmm, I found it, but then I missed it again. Uh, oh yeah, okay. Now I found it. Sorry, like I said, being old is something. Okay, fine. Anyway, this is from Amazon as well. Amazon Web Services. Okay, what is cloud computing? Okay, let's go and have watch it. This one. It's this one. Control C. I'll share this one as well. Okay, here, this is cloud computing. Let me just see CLOU cloud computing. Okay. Who's this? Okay, so this one, let me just edit this one a bit. This is what is AWS. Edit. Okay, let me just here. This is what is AWS. All right, save this. Okay, from the video just now, you can see that cloud computing, among the things that AWS, not one AWS, but cloud computing as a whole, what it does is that it can help you to reduce, these are what they're saying just now, can reduce costs, faster deployment, get you technologies that you don't really have at the moment, and plenty more of benefits. Those are the things that we'll be going through and see in our first module. All right, so enough with the videos. Okay, let's go and see this. Where was it? It's here. Yes, this one. Okay, so cloud computing. Okay, before we go here. Okay, so this one. Okay, then we have cloud computing. Previously, not to say previously lah, in normal cases, not to say normal, okay lah. Dulu punya normal cases, when people want to create or people want to start IT business or they want to start with a technology company, let's say, what they normally do is that they have to build their own infrastructure. They have to get their own server. They have to get the networking done on that particular, in their office for that particular business. Okay, so it is still being done presently nowadays, but people are shifting towards this cloud computing. Okay, reason being, later we'll see, but what we want to do here is that we want to see what are the types that people type of cloud computing that people normally use nowadays. Okay, there are 3 types. They have cloud-based, we have on-premises, and we have hybrid. Very simple. Cloud-based meaning everything is on the cloud. Meaning, for example, if let's say you are using AWS, you are using AWS computation, the server, you're using AWS, database, you are using AWS, your load balancer, you're using AWS, gateway, you're using AWS, everything is AWS. You don't have a single hardware on your premise. Okay, that one is cloud-based. You also have on-premise. This is like the normal one, not the normal one, the traditional IT business. Okay, where you have your own server, you have your own network, your own firewall, so on and so forth, and people are accessing you from the internet to your premise. Okay, that one is on-premise. On-premise also, you can have cloud. AWS also provide racks for businesses, meaning you can use AWS services, and AWS hardware they can provide you and put it in your premise. That one is also can be done. AWS also have that service, but that one is what we call it is on-premise. Hybrid are those that have some parts on-premise and some are on cloud. An example would be like, for instance, you have some confidential data, maybe hospital, let's say, they have patients' data, which you are not supposed to share with everyone. So they want to put it on premise. Or banking. Banking, normally they don't share their, or they don't put their data anywhere else. They should be on premise. Another thing is government. government will not have their data on other people's soil. In a sense, if let's say, for instance, for Malaysian government, our data should reside here, or even our application also should reside on Malaysian soil. They don't. If let's say you have a server in Singapore, and then you want to, okay, we have this, but our server is in Singapore. The Malaysian government say no, we will not be using it because application is elsewhere. It should be, if let's say you're doing it for us, for the government, it should be on the national soil. Okay, so that's the 3 types of deployment models that we have for cloud computing. Okay, so let's go next. Okay, this one. Page down can work or not? Okay, page one. Okay, page down. All right. Sorry, got any message? Can access information from anywhere. Yeah, go. Okay, good. Okay, that one's done. Let me just check whether any messages here. All right. So basically, as I mentioned before, this one, okay, this one cloud-based, okay, done already. Okay, cloud-based deployment, migrate application. Okay, this one is in a sense of how do you go about in migrating your application or your businesses to the cloud. You can migrate your existing application, you can build new application or infrastructure options. The reason why most people will go from migrate from normal or traditional IT of having it in premises to the cloud is one of the things is because of costs. If you think about it, when you have this one just now, when you have it on premise, first thing you need to do is you need to have your capital. You have to have upfront capital to buy the machines, to buy the hardware, which is costly. Not just that, you also need to have a place. You need to rent a office space or ample place for you to put your machines, not including air conditioning, not including electricity, not including the staff that have to maintain, so on and so forth. So most of the people, why they are migrating to the cloud industry or the cloud computing is because of costs. And also when they do that, I think it's in the video as well. What they are doing is that they are migrating, they are pushing the responsibility from themselves to other people. The responsibility of maintaining, the responsibility of making sure that the system is up and running 24/7, the maintenance and so on and so forth are done by someone else. You just pay them. Instead of you paying salary and paying rent, you're just paying a portion of it to someone else to do that work so that you can have more time to concentrate on what your business is supposed to do. For example, if your business is commercial, macam Shopee lah, let's say, your business, you're supposed to concentrating on doing marketing, doing managing the merchandise, so on and so forth. But the IT portion of it, whatever it is on the internet, the website also, of course, you will still have to maintain, but the infrastructure of it, you don't have to care anymore. So that's one of the reasons. Okay, so you can get cloud-based deployment. Okay, so on-premise deployment. This is just to, we are going through this, because I want to explain most of it, the type of deployment. Okay, on-premise deployment, you have a private cloud, you have virtualization and increased utilization is better legacy of IT. Why people are still doing this? Because as I said previously, in some cases, as I mentioned just now, in some cases, there are regulations, there are limitation to whether it's how do you say, whether it is technical or something. There are cases whereby you have legacy software or things that cannot be ported into the cloud. As an example, let's say AS400 in banking. AWS does not provide AS400. So those things, you cannot provision them. Everybody's okay? Still listening? Still okay? Everybody can hear me? Can hear or not? Or can?
Boleh.
Okay. Tak ada macam senyap je semua macam korang dengar ke tak ada? Okay, anyway. Okay, as I mentioned before, there are certain cases whereby you need to have your system on premise. Some of it is because of legacy. Some of it may be because of legislation, regulation. As I mentioned before just now, for example, if it is something that is with regards to the Malaysian governance, let's say, or any country, most of the time, you will not be allowed to have the data reside outside of the country. Okay, so that's one of it. And then there are also cases for legacy software. These are programs that have been running predated like ages ago, and then nobody knows in a sense if it is able to be ported to the cloud. And even though if it is able to be ported to the cloud, it may not work. So those are the things. There are legacies, like for example, as I mentioned before, AS400, you have something like those programs. Let me just at the top of my mind right now is one of our communication programs, which is running on C. That one you will not be able to port it. AWS does have C servers and everything, but if let's say you want to port it, you have to have downtime, which will affect the system, the national system. So those are the things that people normally will not touch, and therefore they will do it on premise. As I mentioned before, AWS also have the services whereby they can give you a rack to use that they can provide you a rack. Inside that rack will be all of their services. They also provide that. Okay. On-premise deployment, which we have virtual, we have also known as private cloud. Okay, this is something that you need to be reminded. Okay, private cloud is also known as on-premise deployment because it is privately owned by the company. And then mostly they will use virtualization, use resource management tools. You have VMs, as either you use VM or you use Docker, either one. Okay, VM and Dockers. Okay, let me just talk about that one, just in case you guys don't really understand what it is. Okay, virtual machines or Dockers are just things that you use inside your server to emulate. Okay, virtual machines are software. Someone told me this. It is software pretending to be hardware. Okay, so virtual machines, you can have multiple virtual machines in one server, meaning, for instance, you have one virtual machine for accounting, one virtual machines for admin, so on and so forth. So those virtual machines will cater for one application, let's say. So those are virtualization. Same thing as Docker. Docker is also a type of virtualization whereby you containerize an application. Okay, later on we will talk more about containers and virtual machines. Okay, increased utilization, better with than legacy IT. All right, so this is on-premise. Many AWS give you a hardware. All right, so page down. Okay, now then. Hybrid deployment. Okay, hybrid deployment is whereby you get some hardware, but you also do something on the cloud. For example, as I mentioned before, if let's say there is a regulation whereby the data is not supposed to be reside anywhere outside of the country, but application-wise, it's okay. This is an example. If let's say that is something that you are facing, you can have the application on cloud, whereby for application itself, the maintenance, the hardware and so on and so forth you will not have to maintain, but you maintain the database, because data is residing on your premise. Okay. Yeah, it connect resources, link cloud to on-premise, maintaining existing application, regulatory compliances keep required records on premise. Those are normally the case for hybrid deployment. There's a few ways of linking the cloud to on-premise, which also we will look into later on. What it means here is that it's either you have your own server or you get it from AWS. It's either one. Okay, but what the main point here is that the hardware or the location where the data or where some of the data is residing is on premise. That's how it is. Okay. Example. Okay. Another example I can give you for hybrid. If let's say you have some legacy application. It can be either or. It can be data. It can also be legacy application. But the database, this is non-confidential data. Let's say you have one non-confidential data. That one can be anywhere, but the application itself is a legacy application. You cannot have it downtime. You don't actually have any what do you call that, hardware anymore to port the legacy application. Okay, you can have that, but you port your data elsewhere. Or you can do your batch processing elsewhere in the cloud. So there's another type of hybrid deployment. You can also do that. Okay. All right. We done cloud deployment. We have done on-premise deployment, hybrid deployment. Okay. Any question first about these three? If not, we'll go into the benefits of cloud computing. If everything is good. All's
No
good.
question. All good.
All good, huh? All right. So let's go to the benefit of, okay. Okay. The benefit of cloud computing, as I mentioned, I think in the video just now also they were mentioning most of the benefit for cloud computing. Oh yeah, regarding this, I have to show you that thing as well. Cloud computing explain, AWS. Let's just go to the resources white paper. Okay, white paper. Okay, you can go to overview of Amazon Web Services. All right. So here also you can see some of the, okay, I'll give you the link. This is a view of, let me just copy this first. Okay, this is stuff that you might want to have a look. Overview of Web Services, enter, and then, is it this one? Yeah, this one, right? Yes, no, not this one. It's this one, correct. Yeah. See? It push. Right. It's not just what is cloud computing, but in a whole, it is I would say most of the stuff that we'll be covering are here. Most of the stuff. So if this will be some of the things that if let's say you want to have more information regarding whatever it is that we are learning in this next 3 days, in these 3 days, you can also find it here. Okay, these are the 6 advantages of cloud computing. This is what we'll be going through. Okay, just now we already gone through on cloud computing, provide simple way to access servers, storage, database, broad set of application, The cloud service platform such as Amazon Web Service owns and maintain the network connected hardware. Okay, so that's thing. Okay, now we go for the 6 advantages. You need to know these 6 advantages of cloud computing. This is something that is essential for you to know. All right. Let me just, okay, I'll leave this for you to read. We will just go through this one. Okay, first of all, we will go into cost efficiency. Let me see, let me put it here so that I can see which one it is. Economy of scale, benefit, rates fix. Okay, all right. Okay, so for benefits in cost, you can see here for variable expenses, you can see for the massive economy of scale. These are words that you will need to understand and need to memorize, especially this one, economy of scale. What does it mean? Okay, so we'll be going into this and this. All right. Okay, so variable expenses, this one is in conjunction with this one, variable expenses. Okay. Instead of having to invest heavily in data centers and servers before you know how you are going to use them, you can pay only when you consume computing resources and pay only for how much you consume. Okay. Oh yeah, another reason why I gave you the slide first. And so just in case, if you have extra notes that you want to write on, you can just paste it here, use it, whatever it is that you need to use, and then get the, for instance, from the example just now, you can just get it from here, and then maybe just copy, and then you want to paste it, for instance, or just an example. You can do this one, I think. Yeah, something like this. Okay, you can just add up to your notes so that you have one place for to, in a sense, to refer to when you want to take the exams. Okay, variable expenses, you pay only what you use. Okay, as I mentioned before, in traditional IT setup, normally you will just, first of all, you have to make your own servers. You have to use, okay, let's say you have a database center, your data center, you need to create a database server, you need to get your hard disk, you need to get your RAM, okay, you need to get your processor. Okay, if let's say you estimate that your application will use a certain amount of data. Let's say, as an example, 1 terabyte. This is just an example. It's not logical, but let's just put 1 terabyte of of data. You need to use 1 terabyte. But because you are running a business, you cannot just take 1 terabyte. You have to take 2 terabytes. One is for production and one is for redundancy. This is not taking into account development, so on and so forth. We are just talking about the business itself. If you are already running your business, you take 1 terabyte for your business, whereby you put all your customer data and so on, and then you need to have another 1 terabyte for redundancy in case anything happened to your main server. So you're already buying 2 terabytes, but you are only using less than 1 terabyte because you estimate it will go up to 1 terabyte. Correct? Betul tak? Correct? Huh? Understand? Huh? Okay. So what it means here is that you have to put up upfront costs to buy things that you will not use. The 1 terabyte for redundancy, you might not use it in the first 3 years or in the first 4 years maybe, because it is redundancy. You need it for just in case, as well as your 1 terabyte of data. starting the business, you may not use 1 terabyte. Starting the data, maybe you're just using 5 gigabytes, let's say 10 gigabytes. What's about the rest of the gigabytes? You're not using it, but you need to still buy 1 terabyte because estimated the business will grow up until 1 terabyte of data. So that is where the variable expenses comes in. You don't need to pay for whatever it is that you don't use. If, for instance, you are only using 5 gigabytes, you only need to pay for 5 gigabytes. And if, let's say, along the line, after a few months, we need to upgrade it, the memory, you may upgrade the memory. Only then you pay. This is what it means by variable expenses. Okay, the next one is reduced maintenance, whereby the infrastructure itself, you don't maintain, you don't buy anything. You don't have a server, so you don't have to pay for electricity. You don't have to pay for the air conditioning to maintain it. You don't have to pay IT for it, less headcount. And it's not really a good thing in that sense. People will lose their job, but in a business sense, people will the managers will look at it as a pro because you are reducing costs. Okay, less time to manage the infrastructure, so you can concentrate more on your business. The income or the portion for maintenance can go into other places where it is more meaningful to your business. Okay, and then we go for economic of scale. Okay, this is what stated here just now. This one, benefit from massive economic of scale. By using cloud computing, you can achieve a lower variable cost than you can get on your own because usage from hundreds of thousands of customers is aggregated in the cloud. Providers such as AWS can achieve higher economy of scale, which translate into lower pay-as-you-go prices. Okay, what this means is that, okay, let me just show you this one again. What it means is that you are paying lower because someone already did some, not to say someone already did massive economy of scale will be like pergi jual borong, pergi kedai borong. Okay, if you go to warehouse, not warehouse, kedai borong is what? I can't remember what kedai borong is. But if let's say you go to kedai borong and you buy things in bulk, when you buy in bulk, the price per piece will be less. Correct? Okay, this is also the same principle that is used by AWS. AWS buys everything in bulk. They have huge data. Not huge data. They have huge data storage. They have huge memory. They have huge processor. A lot of them. And what they do is that whenever you want to, when you go and buy computing power from them, it's not just you, but a lot of people. So with this, they can reduce the price. Okay, later on we'll see also how the economy of scale works when you are getting more processing power or when you are getting more data storage when we go into pricing. But what this does is that when they have a lot of customers, their price that they can give you will be reduced, and the price that they get is in a sense they already bear the cost for the pricing. Okay, all right. So variable expenses. What else is here? Let me see. Benefit, no capacity guessing. Okay, so next is the capacity management. Okay, is there anything here or not about capacity? Yeah, stop guessing capacity, this one. Okay, eliminate guessing on your infrastructure capacity needs when you make a capacity decision prior to deploying an application, you often end up either sitting on expensive idle resources or dealing with limited capacity. With cloud computing, these problems go away. You can access as much or as little capacity as you need and scale up and down as required with only a few minutes notice. Okay, stop guessing capacity is something similar to what I was talking about when you build up your server. For example, the memory space I was talking about, you don't have to guess anymore or you buy upfront anymore. Okay, for example, we are guessing that the memory space that we'll need is 1 terabyte. But let's say your business booms up really, really good. After 6 months, you need to upgrade your memory from 1 terabyte to 2 terabytes, let's say. So you have to go and get a new hard disk. You have to go to make a purchase order. You have to go for the delivery, no, not delivery, you have to wait for the delivery. Once it comes in, you have to put it, install it, and then configure it. So those are the things that you will need to do. Not just guessing about the capacity, but also there are extra work that have to be done when something like this occurs. Okay, this one, that one is if with regards to memory. If let's say the computing power is not enough. For instance, when you start your business, you only get one service, and you think, you think that it should be enough to cater for the business. But 6 months down the line, after 6 months, your business, like I said, booms up. You need more computing power because a lot more. Is that something? Okay, I thought it was okay. A lot more computing power, and then with that, you have to buy a new server, let's say. So with that also, the process goes the same. You need to go and purchase, takes times, need to install, so and so forth. But with cloud computing, the launching of resources as you need. You just buy. Like in AWS, you launch an instance. The instance is like your application lah. You just launch your application, and then if let's say you see, oh, we need another one, so you just buy another one, and then it can be up and running in just a few clicks. In a few minutes, it will be up and running already. So you don't need to have to waste time, and also the amount of money that you have to pay, just now, the upfront, this one, the variable expenses, the upfront money also, you don't need to pay so much because you don't need the whole server. So that's where the capacity management comes in. That's what it says here, when it means by you often sitting expensive idle resources, dealing with a limited capacity. Without computing, these problems go away. You can access as much or as little capacity, as little capacity. You can scale up as well as you can scale down. Okay, as I mentioned just now, you can scale up in that sense. You can buy it. You can just upgrade or add another instances, as well as you can remove instances as how you want it. Any question first? Macam semua orang macam dah, I know, 5 more minutes and then we take our break. Still okay, huh? All right.
Okay.
Okay. All right. Pay as you use, as I mentioned before, as I said just now. If let's say you need one instances only, or one application only, one PC only, you just buy one. If let's say it is time for you to upgrade your application, you need to upskill your business, then you can get another one. So you pay as you use, not instead of in the traditional model. If let's say you estimate the growth of your business in 1 year, you need to have 5 servers. So upfront, you buy 5 servers already. But in the first year, you're only using 1 server. So the rest of the 4 servers are sitting idle. So those are the things that you will not have to face with cloud computing. Okay, scale on demands, in a sense, just like just now, when you see that your business goes up, you can upscale it, you can get more resources. And if let's say your when there are times that where you can see that your business is not doing so good, you can downscale your business. Okay, so that's the one. Anything else? Okay, speed and agility. Okay, we go through this one really quick because this one is increased speed and agility in the cloud computing environment. New IT resources are only a click away, which means that you can reduce the time to make those resources available to your developers from weeks to just minutes. This results in drastic increase in agility for the organization, since the cost and time it takes to experiment and develop is significantly lower. This is what I was saying just now in the process of, for example, of getting a new hardware. If you want to get a hardware, you have to go and get a purchase order, go look through the catalog first, decide, discuss with your developers, so on and so forth, make a purchase order, wait for the delivery, hook it up, only then you can use it. But with cloud computing, you can just have it up and running in a few minutes. Just create it, set the settings, so on and so forth, and then you can have your what do you call that? You can have your hardware running already. Okay, so resource access, you get new resources quickly, or time to obtain resources in data centers. Traditionally, you can take weeks, like I said just now, purchase order, purchase, delivery, so on and so forth. Availability, continuous access to the resources you have 24/7. Okay, so that's the one, speed and agility. Next one will be global reach. Okay, what it means by global reach, I think is stated here as well. This will be the last one, I think. Stop spending money running and maintaining data centers. This is about maintenance just now. And then the last one is go global in minutes. Easily deploy your application in multiple regions around the world with just a few clicks. This means that you can provide lower latency and better experience for your customer and at minimum cost. This one is also mentioned in the video we saw this morning. Because AWS is present in mostly all over the world, later on I'll show you the map for AWS. You can deploy your business instantly. Just like, for example, you have a customer in US, or tak nak US lah, kita letak tempat lain. You have your customer in Brazil. Let's say you have a customer in Brazil, but you don't have any data center or you don't have any service in Brazil. Be a bit slow. But what you can do is that you can select one of the region. You can select the closest region in AWS to as close as Brazil, and then create one instance there, so that whenever they want to access your application, they can just go to the Brazil sites. So you can, in essence, for you to access the global market, it will be so much easier. Okay, it says here, deploy application to customer worldwide with low latencies regardless of their location. As I mentioned before, AWS global architecture. I think that in the video also they showed you the world map, and then they have dots, where they have all the AWS data centers in most of the regions. So you can just pick any regions, deploy your instances there, and then have your customer access your business. Okay, this is what we call that we are borrowing on their market footprints. They already have a market there, so we just borrow their footprints, just following whatever it is that they have. Okay, Okay, so it's 31. It's 1 hour and 30 minutes. We'll have 5 minute breaks. Is it okay? Is it enough for you guys? 5 minutes or 10? 5 minutes lah eh. Okay, 5 minutes. Okay. Huh? Najmi, anything?
It's okay.
Okay, yeah? All right. So 5 minute breaks. We'll start again at 10:36. All right. So you can just go and have a drink, uh, vape oxygen or anything that you need. Okay? Okay, see you in 5 minutes. Okay, everybody's back. Okay, we continue on with the global reach. Just now, I mentioned that I'll show you the region or the availability of AWS. So you can see it here on AWS main page. You can just go to the home page, and then you can see here that they have not to say offices, but they have data centers in North America. So this is for North America. They have one. They have for South America, Sao Paulo, Chile. In Europe also, they have quite a few number of them. In Stockholm, London, Milan, Paris, Spain, Zurich, so on and so forth. And then you have it in Middle East, and then Asia. Africa first. Okay, Africa one from second down here in Cape Town. Yeah. And then you have in Asia Pacific, you have in Singapore and also in Malaysia. Okay, you have a few of them. You have Malaysia, you have Singapore, or you can see Malaysia. Malaysia kena nampak. You have to show. Yeah, where was it? Yeah, there it is. Okay. So you have Malaysia, you have Singapore. Here, Malaysia, Singapore, Thailand, Indonesia. Okay, Osaka also they have, and Osaka is there here in Japan. Okay, and then anywhere else? Okay, Australia and New Zealand, all the way down under here. Okay, so as I was saying, if let's say you have businesses or you have customer in any part of the world, you can just choose one of the region and then deploy your application so that your application will be closer to your customer and to reduce the latency. Okay, so this is one of the things whereby you can go global in just a few minutes. All right. So again, the 6 advantages. You trade fixed expenses for variable expenses. You don't have to buy first. In that sense, whatever it is that you need, you just pay as you use. You don't need to care about maybe next year you need to add some more whatsoever. If you need to add, you add. If you don't need to add, you don't need to add. So it is for variable expenses. For massive economic of scales, because AWS achieve higher economy of scale, which translates to lower pay as you go, because AWS already have buy it in bulk, and then they have a massive amount of customers, so they can give you in a lower price rate. Massive amount. The economy of scale, you have to remember economy of scale, you have the in that sense they have hundreds of customer aggregated cloud, they already bought it for you and then you just use it. Okay, stop guessing capacity. You can upgrade or you can downgrade your resources as you need. Increase speed and agility in a sense of to be able to upgrade. It just take you few minutes. Okay, and then stop spending money running and maintaining data centers because you don't have a data center anymore. You don't need to maintain electricity. You don't need to maintain the resources for maintenance. You don't need to pay for the licensing anymore. So all of those will be reduced, and everything is handled by AWS. Yeah, okay, the last one is go global in minutes. All right. So in a way, what we have covered in chapter 1 is regarding what is cloud computing and the advantages of going for cloud computing. Also, we learn about the type of deployment, the cloud computing deployment. You have private ataupun on-premise, you have hybrids, and you have total cloud deployment. And then you see about the benefits and the advantages of going to cloud computing. All right. Next, we'll go into some questions. Okay. First one, what is cloud computing? You can just type A, B, or C. Backing A is backing up files that are stored on desktop and mobile devices to prevent data loss, deploying applications connected to on-premise infrastructure, running code without needing to manage or provision servers, on-demand delivery of IT resources and application through the internet with pay-as-you-go pricing. Oh, D. Banyaknya D. Okay, so answer is D. All right. I don't think I need to tell you this, but I'm just telling. If you remember when you are taking SPM, I'm guessing that all of you have passed your SPM. So when you're taking SPM last time, they have something like this, right? A, B, C. And normally, jawapan yang paling panjang sekali tu is the one that normally is the correct answer. Normally, but not all the time. But in most cases, you just read it and then yang panjang yang explain banyak sikit tu, sometimes, most of the time will be the correct answer. Just keep that in mind. It's the same as when you are taking it in SPM last time. All right, question number 2. What is another name for on-premise deployment? I mentioned this just now. A is private cloud deployment, cloud-based application, hybrid deployment, AWS cloud. Okay. Okay, good. Everybody is saying A, private cloud. Okay, good. I think this is the last one, number 3. Okay, how does the scale of cloud computing helps you to save costs? This is something that I was saying, the economic of scale. You do not have to invest in technology resources before using them. The aggregated cloud usage from a large number of customers result in lower pay-as-you-go prices. Accessing services on demand helps to prevent excess or limited capacity. You can quickly deploy application to customer and provide them with low latency. B. Anything else other than B? Let's see. Okay, nothing else other than B. Okay, so the aggregated cloud usage from a large number of customers result in lower pay-as-you-go prices. Okay, key takeaways from this will be the cloud computing on-demand IT services via, what is cloud computing? Is on-demand IT resources via the internet, and you pay as you go. Deployment models, there will be the cloud models, which is everything runs on cloud, on-premise, which is everything runs on-premise, and hybrid, whereby you have half and half. Half is run on cloud and half you run on-premise. Okay, AWS benefits, they have cost, capacity, speed, global reach. Have to remember all 6. They have 6 here. Of course, I stated it like this because there's 2 in cost, if I'm not mistaken. 1 in capacity, speed, global reach, 2 in capacity, I think. 2, 1, and 1, if I'm not mistaken. So there are 6 altogether. So just remember these 6 advantages of cloud computing. This one. All right. Okay, so before we go into module number 2, we'll have a short quiz. Okay, as I mentioned before. Oh yeah, I didn't tell you one thing, right? Okay, let me just go and have a look at that one. The time for you to do the exam. Exam guide. Let me just see here. Does it mention here? I think it was mentioned here. Okay, let me just have a look. Okay, it's not. Maybe it's not there. Minutes. It's not. Okay. So anyway, your exams is 65 questions and it is for 90 minutes. Okay, let me just do the calculator first. Let me just come up with the calculator. So you have 65 questions and then we need to divide it with 90 minutes. So it's about 0.7 per, is that correct? No, 90 minutes divided by 65. No. Doesn't make sense, that one. Okay, 90 minutes. So divide with 65 questions. So you have 1 minute, 1.4 minutes, which is 1 minute 20 seconds. So also, okay. Per questions, that's the amount of time that you should allocate per questions. All right. Let me just go here and give you the first quiz of the day. Okay. Let me see. Close this. Okay. Okay. Stream is updated. All right, fine. Sure. Okay, I already shared one quiz. Okay, so instruction. This is the quiz. Let me know if you have problem accessing the quiz. Maybe I need to change some settings, maybe. So let me know first. So all of you able to have a look at that quiz, able to access the quiz.
Can, sir.
Can I? All right. So there is 10 questions. So as mentioned before, you are supposed to be allocated about 1 minute and 1 minute and 25 second or so per question. So we will reduce that a bit. I will give you 1 minute per question. So I'm gonna set a timer for 10 minutes. Let me see, timer. One zero. Okay, 10 minutes. So you can start your quiz now. Okay, tak payahlah. Or is it stopwatch? Mana lah. Sekejap. Then, how do I do this? Oh, edit it first, is it? No. Stopwatch. Close this. Oh, okay. That should be okay. Timer doesn't work. Anyway, we'll just use the stopwatch. 10 minutes. Okay, 1 more minute left. I can see 18 people have already handed in. We have 22 students. So another 4 have not handed in. You still have 1 more minute. Half a minute. Fifteen seconds. Three, two, one. And time's up. All right. So we have 19. 3 more have not handed in. Please hand it in as soon as possible so that we can go through the questions. So how was it? Easy, right? No halah. Okay, it's supposed to be a very simple one. I think about one question or maybe 2 questions that I have not touched at all, but shouldn't be that hard. Okay. Let me see. 19. Sure, everyone hand in already? Or am I just 19, huh? Correct, huh? 19? 19 people only? Okay, anyway, if that's all of them, so 19 people or 19. Okay, from what I can see, most of you are getting very good marks. 10 got full marks, 5 got 9, and 3 got 8. Okay, which is a very good score for your first quiz. Okay, let's go through the questions. This is the one. Okay. Question number 1, introduce AWS. Okay, introduction to AWS. 10 question. Which of the following best defines cloud computing? It is C, the on-demand delivery of IT resources via the internet with pay-as-you-go pricing. As I say, normally the one that's the longest jawapan tu would be the correct one. Normally, not normally, usually. Which of the following is not a cloud deployment model? How many cloud deployment model do we have? We have 3 cloud deployment model, which is on-premise. So definitely on-premise is wrong. Here it says not the cloud deployment model. So on-premise, we have cloud-based, which is totally on cloud. And also we have a hybrid. So the answer is D, which is not the, what I call that? The deployment model for cloud computing. Okay. So number 3, what is one key benefit of AWS cloud computing? A is high capital expenditure upfront. B, fixed infrastructure regardless of demand. Variable expense based on usage, and inflexible scaling. So the answer should be variable expense based on usage, is pay as you use. One key benefit, fixed infrastructure, definitely not. It's not a fixed infrastructure. We can always upgrade it. High capital expenditure, first upfront. No, we don't have to pay anything upfront. Inflexible, meaning not flexible at all, which is, yes, it is not inflexible. It is flexible. Okay, so variable expense based on usage. Okay, number 4, what enables AWS to offer lower cost to its user? This one is the one that we were talking about just now. Okay, upfront purchase of hardware? No, definitely not. Manual server provisioning, massive economic of scale. Whenever it is AWS can lower cost to its user, it's because of that massive economic of scale. A lot of people are using them with AWS, so they can give you a lower price. Okay, macam burung, like I said. Okay, in a hybrid deployment, where are the resources hosted? Hybrid deployment, meaning you have both parties. You have on cloud as well as on premise. You have the marriage of two models. Okay, only on premise. This one is on premise or private. Only in the cloud. This one is cloud based, only cloud. Partly in cloud and partly on premise. On a personal computer, definitely not. Okay, so C. Which AWS service is an example of compute resources in the cloud? This one we have not touched. Like I said, there are questions that I have not touched yet, but is like the questions, like the exam, there should be a few questions. That's the thing that I forgot to tell you. Normally the 15 questions that they will give you will be questions from other exams, like architecture, the AWS architect, or AWS some other what I call that, maybe some other features that is not included, so they will just put it in. So you can regard this one as one of those questions, but of course I'll count it. All right. Anyway, which AWS service is example of compute? Compute one, I'll just let you know now. S3 is for storage. CloudFront is for company delivery. EC2 is elastic compute. So this is the one. IAM is for security, but which we will cover in the next one. We will cover this one, EC2. Okay, what does on-demand on-demand delivery means in AWS context, only in AWS context. Delivering via scheduled batch. In a sense, you have certain timing and then you deliver. Deploying software once a year, accessing IT resources as needed, paying an annual license. So it is as needed and on demand. When you demand it, when you need it, then you can access it or you can get it. Okay, which model describe a traditional IT setup? Located on company premises. This one will be the model for on-premise. Okay, which model describe on company premise? This cloud native? No. On-premise, multi-cloud, elastic computing. So this is the one. Okay. Okay, number 9 and number 10, which is what AWS features allows you to avoid over provisioning resources. Okay, this one also we have not touched, but I will preventive billing. This one is about when you over. Okay, first of all, the question is about over provisioning resources. In a sense, like you only need 10 gigabytes of storage, but you are getting 1 terabyte of storage. It's provisioning. So preventive billing is for cost, regional zoning is for high availability, reserve instances is for what to call that compute. Is this one is the elastic scaling. You scale it as you need it. Okay, which AWS benefits help companies move quickly into global market? This is the last benefit that we talked about just now. Auto scaling is to either you scale it to get more instances or get more resources. Data replication, go global. This is the one, the last one that we talked about just now. Okay, so that's the answers for the questions. Anything from the questions? Anything that's confusing? This is only first portion. It's not really that hard yet. So any question first before we go into the next module? Nothing? Good. Okay.
So far, so good.
next. So far, so good. Good. Thank you. All right. So next we will go into cloud computing, the type of cloud computing. Oh no, this one is done already. Type of cloud, hybrid just now, global infrastructure. We are going into compute, global infrastructure. Okay, this one is the region just now, security and compliance. Later we'll look into this. Blockchain. Compute, we are talking into this one. All right, this is what we'll be going into in where was it? This one. Yes. Okay, compute in cloud. All right, we will learn about Amazon. Okay, this one I'll show you first where it is. This one, module 2. Okay, so for module 2, what we'll be looking at is that we will be looking at the, okay, let me just put this one here. Okay, the not how to use, but how do we use EC2, which is one of the services provided by Amazon. All right, and then we identify and the different EC2 instances, we differentiate between various billing options that is provided, how to load balance, because EC2 is the processing, the compute power behind it. So how do we balance if, let's say, network traffic is coming in, and then how do you balance it into certain into which instances should it go to? All right, so we will look into elastic load balancing and summarize the differences between Amazon simple notification service, the SNS and also the SQS, and then the summarization additional. Okay, fine. So this is the things that we will look into in module number 2. Okay, so module number 2, I have it here already. Okay, compute in the cloud. We will look into EC2, which is one of the component or one of the services provided by AWS. Okay, so if let's say you go to AWS, this one, so this is the compute. This one will tell you the auto scaling the image. Like say we'll not go into it. We'll go into compare. What is it? Okay, this one also not so much. We will not look into it so much, but we will look into EC2, the instance type, and then okay, we have all this family, which we will see later what it is, and then we will look into auto scaling. Image builder, we will not look into it. Okay, that's about it. I think this one, only these two. But on my PC, on my presentation, it will be a bit more. Okay, load balancing as well. Okay, so completing. Okay, so here, I'm not sure whether you have an account or not. If let's say you don't have an account, you can create one. You can create an account. It's free, in actuality. Okay, let me just show you first. If let's say you are interested in trying it out, be mindful, please, because you will be giving your credit card number in, for the registration. And if you are not careful, you'll get billed, because whenever you are using the AWS services, they will charge you. But of course, going in, registering, you do get a free tier. In a sense, you will get a free account whereby you can try a few things. Okay, you can just sign into an existing, verifying. Okay, you can try AWS at no cost for up to 6 months. You can do this. Start with 100 USD in your credits, and then you can earn up to another 100 by completing various activities. There are activities such as tutorial inside there. If you go and finish it up, then you get up to 100. You can get a few dollars, maybe a $10 per exercise, something like that. Okay, this is just to promote people to try it out and then use their services. Okay, where was it? If it is a new account, sign up for and then root user. Okay, I have one for me. Account name. Okay, I'll just log in first and I'll show you where to sign into console. This is just to show what is EC2 and where can you get EC2. As I said just now, you can sign up. It is free, but like I said, you have to provide your credit card. It's either your credit card or your Visa bank account. It's either one. Like I said, again, be mindful about when you're using it, so that you don't get charged. And then another thing is that when you try to sign up, they will ask you to verify. Once you give your credit card number, they will ask you to verify your phone number. I think it is a phone number. I think they will verify whether you are real or not. So you need to either ask them to call you or SMS you. For me, I ask them to call me. It's a robot that called me, and then I verified the for the accounts. So you can do that as well. So let me just have this. This is IAM. Oh, this is IAM user. I'm not supposed to use IAM user. I am not a IAM user. This is IAM user login. Where is the code? So sign in using your root user. Okay. This root user and IAM We will about it more when we go for security. Okay, this is how the security works with AWS. Okay, there you go. No, this is not the one. That one is the IAM user. Sorry. Uh, okay, mail, password, ever, and then my FA. Okay, this is a multi-factor access. So that one also a part of security. Where did I put that? Okay, here we go. Indicator. Fingerprint. 530. 1. Okay, able to access. All right, sure. Okay, this my account is a free account. I created like what 2-3 months ago. Okay, so like I said, you can also create your own free account if you want. For EC2, it's either you can. This one is because I used some of them. I tried out EC2. Okay, you can go to EC2 here. Okay, EC2 stands for Elastic Compute. Okay. So this is the dashboard. How come it's so slow here? All right. So this is a part of the services. Okay, so this is how it looks like. Okay, let's go through what EC2 is. Okay, compute in cloud. Okay, EC2 overview. It is a secure, resizable compute virtual server in the AWS cloud. Quick provisioning, launch instance within minutes, pay as you go, pay only for running your instances. If you're not running your instances, you are not being billed. Okay. The thing about AWS or the services that Amazon provides is that if you run or if you use the resources, they will bill you because that's how they make their money. So you have to make sure that if you are not using any instances or if you are not using any of the resources, do shut it down or delete it. That way you will not get overbilled. There are instances whereby people just create an instance, try it out, and then leave it running up until they get billed. So do be conscious about that. Okay. All right. So next one. Okay, how Amazon EC2 works is that you select a template. What EC2 is first of all. Okay, EC2 or Amazon Compute Cloud. Okay, let's go and let you see this one. Okay, what it is that it is giving you a virtual server. Good. It's giving you a virtual server whereby on that particular server you can put in anything you want. You can have it run your application. You can have it run your web services, let's say. You can have it run as your what else is there? Okay, other than services and web. Okay, it's either one of those. You can do whatever it is that you need onto the EC2 because it is a virtual computer itself. It is a computer. Okay, let me see. So to launch it, you just have to set what type of OS do you prefer on that particular computer. Now, what is the family in a sense? What is the computing power that you need to have? The RAM, and then the storage, the data, how much memory do you need? And then I think that's about it. And then you just write it. And then you pay, if I'm not mistaken, the pricing for it is, let me just see again. I can't remember the pricing. I still have 139. Okay. See, they give me $100 initially, but instead of using it, I'm getting more because I completed most of the tasks that they've given me. Okay, anyway. Okay, this let me just okay, let's create an instance. Let's say, let me just create an instance. Let me just go launch instance. Okay, so here you can see, okay, this is the template that they were talking about. What you need to do is that you create a template. What is it that you want? What type of OS you want to have? You want to have Mac? Tak pernah pakai Mac. Let's say you want to have Mac OS. Go ahead. You can choose it. You can have Ubuntu, which is all of this are Linux. You can have Windows as well. Debian. So some of the current setting, I'm okay, fine, whatever. Open changes. Somehow or other, my internet is so slow today. Somehow. Okay, this is the one. Okay, for free tiers, you can have all this because mine is free, so you can have all this. If I'm not mistaken, Mac have to be paid. If I'm not mistaken, Mac is paid. Oh, is it? Oh, free tier eligible also. Free tier eligible. Mac Ventura still okay. Windows. So whenever you are signing as a free tier, they will tell you what is it that you're eligible for and what is it that you are not eligible for. Okay, description, and then these are the instance type. Okay, so here is free for free tier eligible, and then you will have some that will need to be paid, like this one. So you can see here on demand window based pricing is 18 USD per hour. If you run your instance for 1 hour, you will get billed for 18 cents. Might not be so much if it is for an hour. So if let's say you do have your business running 24/7, so that's the amount of money that you need to pay for one instance. 18, let me just calculate it for you. Let's just take S3 large as an example. They do have convention, free tiers, that the T conventions, and then you have the S, the C, and the M. Okay, let's just take this one for example, 0.18. Let me get my calculator again. Calculator. Okay, this one. Is calculator. Okay, let me just put it here. So it is 0. Okay, since I already have the 0.13, this is too cheap. 1 cent. Let's take something that is a bit more expensive, which is a higher power one. Okay, this is very expensive. $2 one is very expensive. We take lower one. Okay, 0.8. Let's say 80 cents. Let's say 80 cents. They have a 20 cents per hour, if I'm not mistaken. Let me just go and have a look. This is $5, $3. Okay, okay. This is the 40 cents. 40 cents per hour. Okay, let's just do a calculation here. 40 cents, 0.4. 40 cents per hour. We multiply it with 24 hours. We run it for 24 hours. And then we multiply it with 7 days a week. Okay, so that will give me $67 per week. Okay, multiply it with 4 per month. Okay, I will get $268 per month. Okay, if I run my business for the whole year, multiply it with 12. This is the amount of money that I need to pay to have my server running for the whole year. Okay, not that exaggerated in a sense. It is only $3,224 if you multiply it with what, 4.5 right nowadays. Ke berapa? Let's say just 4 lah. Multiply it with 4. So that is the amount that you have to pay per year for a server. But this is a higher tier. I think this one, the C just now is a higher tier one, which is where was it? Oh, 40 cents. 30 cents. I can't remember what was it, huh? Which was it? I chose this one, I think. The metal, which is a C grade, 64. Okay, 64 CPU, 128 gigabyte of memory. This is the RAM. And then you have on demand. Okay, no, this is $4. Sorry, not this one. This one, I think, 4 cents. Yeah, something like this, 4 cents. So 8 core, 16 GB memory, current generations, Ubuntu. Okay, if you are running on Ubuntu, it is 43 cents per hour. Okay, the C grade, let me just see a C family. What is C family stands for? I can't remember. C family stands for high performance computing. This is mostly what we use for batch processing. So it depends on what type of usage as well that you want to use. If let's say you are more for general use, if let's say it is just for web services or something like that, you can just go for general compute power. If let's say you want to use for maybe high processing, or you want to use for database, some things like that, you have to define what family. It's the same as when you want to go and buy your own server. You have to define the spec, what kind of specifications that you need for your particular server. So that's how it is. And then you will have, this one is to log in. Then you have networking, meaning you can you are allowing traffics from everywhere. Do you allow HTTPS to your server? Do you allow HTTP to your server? And then what else is there? Okay, so this is what you can, in essence, what is it that you need to do to create your instance or to create your server. Okay, this is what it is. All right, so I don't need to create an instance. I'm just showing you how it is. All right, okay, there's one running. Okay, let me just stop this. Not supposed to have anything running. Okay, anyway, let me just delete. Stopping. Wait, just wait for it to stop, and then you can just delete. Okay. And it doesn't even have a name. That's weird. Okay. All right. So go back to our slide. So we just need to launch them, and then you can connect to your instance. Just like just now, I showed you the connection. It's either you can connect to it using SSH, you can connect to it using PuTTY if you want, SSH, normal terminal, or you can connect to it using HTTP or HTTPS. Remember the chat that I showed you just now? Those are methods of connecting to it. There are multiple methods, and then you just run. You just use it. You can install, if let's say once you have it run, you can install PHP, you can install Nginx, you can install Redis. So whatever application that you want, you can install his what do you call that? MySQL, Postgres. Because it is like the whole computer, whole server. Just do whatever you want. Okay. Okay, let me just see. Is it stop? Okay, stop. So I can just delete. Just check first. Okay, okay. Distance. Terminate. Terminate. All right. Okay, terminated. All right. So in an instance, you can also, this is the instance type. Like I was telling you just now, there are multiple types for an instance. Okay, I think we will cover it here as well. Okay, let's just go through the slides. Okay, this is the instance type. Okay, we'll go through one by one. Okay, there are 4 types for an instance. you have general usage, which is like everyday normal usage. If let's say you want to deploy a web server, or you want to deploy a, what else is the normal cases? Testing server, let's say, and you want to create some PHP application, or you want to create some application and put it a VoIP server, let's say. VoIP server is not really that intensive, so you can have on a general purpose server. Cool. So you can do it as for a Git repository, code repository. You can use it as for web server, so on and so forth, whereby you have a balanced compute memory, and then also for networking. The general purpose are normally denoted by T and M. Okay, if you see here, you have a C, you have an I, CRM. Okay, M is also one of the general purpose. Yeah, M is also a general purpose. You can have ARM, memory, and then the storage, and then whether the storage type is SSD or whatsoever. So these are all the instance type. The one that I chose was a T. Let me see whether they have it here or not. Go down some more. Okay, T. Okay, you can have a T, which is also a general type. 64 architecture, quad octa-core, and then you have 32 GB of RAM. Storage, you can add storage here. The storage type, moderate performance is moderate, so you can just have that one. Okay, so you can see there are multiple type that you can create. Okay, so as stated here, let me just go back to the slide. You can have a general purpose, which is for web service, web server. Also, you can have something which is compute optimized, which is really high processing power that you need for, let's say, you want to use for image generation or something like that, or gaming server. Gaming server or batch processing. You can have a high performance processor, okay, let me see, the compute processing should be a C type. So you can see here, C type large, this one. Okay. You can have this one also, C type, which is also one of the compute type. Okay, next one will be this one, sorry. Okay, compute and then memory optimized. Okay, memory optimized is basically when you have high read and write. Okay, for instance, fast performance for large data sets. So if you have a database and you want to have it, what do you call that? Frequent read and write processes, you can go for a memory optimized. Okay, right, let me see. Anything else here? No questions? No, okay, bye. Okay. All right, so storage optimized, you can basically you want to have for warehouse archiving, so on and so forth, high sequential read and write access. So these are the type of EC2 that you can create. Based on the time, they will determine the architecture, in a sense, what is the processor that you will need there. Of course, you can update, you can change for your own customize. Also, is available as well. Okay, so general purpose. Okay, we went through general purpose. We have anything else after this? Okay, pricing options. Okay, saving. Okay, this one is later on. So anything regarding this first, like general purpose, you can have it for backup server. Also, you can what else is there? If let's say you are running a small businesses, you don't really need to have a high processing. You can go for general purpose, compute optimized. You can have, like I said, for gaming, for video intensive something like that, whereby editing, you can go for compute optimized, memory optimization, where basically for database, if let's say you are running it for SQL, for MongoDB, you can find, can also, any database application, you can have a memory optimized, storage optimized, you can have it like for archiving, for filing and stuff like that. Okay. If let's say you have records, so you can get it inside that. All right. So next we will go into pricing. Okay. As I mentioned before, AWS, the core business is with regards to how many people are using it and how frequent people are using it. So they make money by whenever you are using their resources. So you need to be very careful in choosing what instances and how do you manage your instances. Okay, the pricing options for EC2, let me see, do they have it in the pricing? I'm sure they have it here. No, they don't have it. Okay. Okay. Anyway, no need for the calculator anymore. Okay, let's just hope for this. Okay. I keep hearing this ding 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 ding. I'm not sure whether is it any messages or something like that. I don't see any messages. Okay. But anyway, all right. Pricing option, it is on demand. When you want to have an EC2, there are a few things. Okay, this is with regards to if let's say you are starting your business or you are a project manager, and then you are doing costing. Okay, if you are a project manager, you are doing costing, you want to know how many, first you have to take how many resources, and then you want to get how much that you need to spend for servers, for the allocation and stuff like that, your budgeting. So you need to know which EC2 instance, not just EC2 instance, but which package for the EC2 that you need to take. Right, there's a few plans that AWS provides for EC2. First one is the on-demand. This is no upfront cost or commitment. You pay as what you use, just like just now. This is an example of it. If, where was it? This one. If let's say I go for I have one instances, this one. Okay, let me just refresh this. Okay, I have one instance. Still running. There's one more running. Oh, forgot. I created a template. Damn it. Yeah, later. That one I created one auto template. That means I will have it running all the time. I totally forgot all about it. Okay, anyway, if let's say I'm using it, then if it is running, then they will start billing me. This is what AWS is. So this is on demand. Normally, what people use on demand for is if let's say you are testing out something, you're testing out your program. Let's say you are testing out your program, and then you want to see whether how does it behave, people connecting to it, so on and so forth, whether it's working or not. So you can have it on demand, meaning you don't have it working 24/7. So it is, if you are still in the development stage, it is a good option to go for the on demand. Okay, understand, huh? Okay. For irregular, in a sense, you don't know when you'll be working, when the server is supposed to run, when it is not supposed to run, so on and so forth. So it is good to have the on-demand pricing. In a sense, the package for the on-demand. Right. So the next one, you have the reserve instance. Okay, reserve instance is whereby you tell AWS, okay, I'm gonna be using this particular instance for 1 year or for 3 years. They have two types, whether you want to have it for 1 year terms or you want to have it for 3 year terms. Okay, you have to tell this one. If let's say you already know you don't need to do the development anymore, you already have a ready setup and you just want to run your application. And in the end, you know that you're going to be having your application for 1 year. And then after that, you're going to upgrade, let's say, you're going to use another application, maybe. So if let's say you already know your business plan for 1 year or for 3 years, then you can opt for this particular pricing. It's a reserve instance where the billing will be lower than the on-demand because they already know that you'll be using for 1 year. For instance, for example, just now, 1 year we'll be paying for 12,000. But for this one, for this reserve instance, instead of 12,000, they can give you up to 72% of saving. So instead 12,000, maybe you just have to pay them 3,000. Okay, for 1 year. Understand? Huh? So it is a better option, but you have to stick with them for 1 year. Because they know that you'll be using it for 1 whole year. Okay, the reserve instance, I'm not sure that's stated here or not. Let me just have a look. Okay, reserve instance, they have two types of reserve instance, which is good. They have it here. Okay, reserve instance, they have a standard reserve and they have a convertible reserve. There are two types of reserve instance. Okay, standard reserve, meaning you already specify the instance type, the size, the platform, the tenancy, 1 year or 2 years, and in which region this particular application will be running. When we are talking about region, is this one. Okay, currently I am on Asia Pacific region. So my service will run on the Asia Pacific region. Okay, so this is what we call region. If let's say you want to have your application running on a different region, if let's say you want to have in Europe, let's say for London, okay, you can change your region and then have your application run on that particular region. Okay, understand? Huh? So for, like I said, I'm not sure why my internet's so slow today, but anyway, so this one, you already specify what instance type, and then which family that you want to use, the size, the platform, the tenancy, and then the region. You already specify. It's fixed. You can't change them. Okay. Specify specific regional for capacity reservation. This one is optional, and then you get a very good discount. Okay, the other one of an instance type, it is still 1 year or 3 years of tenancy, but you are allowed to change your instance family, the OS, the tenancy, and payment options. This is the reserve, the convertible reserve package. It is more flexible, but you will not get a lot of discount. Okay, if your business or if your if your business have not, it's not fixed yet, you are still maybe still starting up, you're not sure yet, but you want to go for something that is more flexible workload, you can go for the convertible reserve, which gives you more flexibility but less discount. If let's say your business is already matured, you already know what it is that you want, and you know that your business is going to be running for the next 1 year or 3 years, you can go for a bigger discount whereby you fix everything and then have it run. Okay. Again, this one you can change the instance. The instance family is the one that I was showing you, whether you want to have it for optimized, memory optimized, compute optimized, general usage, so on and so forth. And then the size, the platform here is the OS, whether you want to run it on Windows, the Linux, so on and so forth. Yeah, okay. All right, so next one will be the saving plans. Okay, so on demand, there's only one type. Reserve instance, they have two types, which is the standard reserve and the convertible reserve instances. And then you will have saving plans, which are hourly spent commitment, flexible instant usage. What it means here is that okay, an example is like this. Okay, an example is like this. You know that your business runs from 9 a.m. to 5 p.m. daily. And this particular application is just used for your business, or your office, let's say. And afterwards, you're not going to be using it anymore. Oh, after 5 o'clock, it's going to be shut down, not going to be using it on weekend, so on and so forth. So you can opt for something like this. It is committed per hour, but there is a tendency the commitment to it. I think it's a 1 year or 3 years as well. The per hourly spend commitment with the instance family, like just now, you can see, right, it stated that how many hours and stuff like that. Okay, so in London, I don't have any instances. I can launch an instance if, let's say, I create one instance. Okay, let's go back to Asia region just now. Asia, Singapore. Okay, so if let's say you know that instance type, okay, so here you can see this one is running per hour. Does it stay here? Pricing per hour. So you can budget your expenses if that is the type of instances that you need. You're only using it for a certain amount of hours. Okay. On-demand rates will be this one, but for instant saving plans, you will get a discount whereby because you already stated how long your term contract will be. It's either 1 year or 10 years old. So instead of paying maybe 80 cents per hour, you can get maybe half of it or less than that. Okay, not sure how much percentage, but there will be percentage of discount. But be sure that you stay within that hourly arrangement. If you exceed any usage that is beyond the commitment, it will be charged at a regular on-demand rate. So understand, huh? If let's say you already tell AWS on your what do you call that? On your agreement, it's already stated that I'll be using this instance from 9 a.m. in the morning up until 5 p.m. in the afternoon. If let's say one of you guys go and turn on the instance after 5 p.m. It will get charged at this on-demand rate instead of the saving plan rate. Just be sure that you keep that in notice. All right. If let's say you have a flexible, like I said, if you have a flexible hours that you know how much that you'll be using, so this is a plan that you can afford. Okay, but it will be charged by hourly. All right. So next one. Saving plan. Okay, next one is a spot instance. Okay, let me see. Do I need to give you anything else on this? Okay, I think that should be it. Anything else? Let me just go and see whether they have. Reserve auto scaling. Okay, tak ada. Alright, so let's go for spot instance. Okay, spot instance ni is where you are using the unused EC2 capacity. Okay, what it means is that if let's say AWS have 50 instances, right? If 50 instances available, okay, and at that particular hour, only 2 instances are being used. Okay, they have 5, only 2 are being used. So they have 3 unallocated instances. Spot instances will give you these 3 instances. If let's say you say I want to use spot instances and I want to create 3 instances, so they will give you these 3 because it is the unused one. But if, for example, when you are using it, someone else who already paid for the instance start using it, so they will stop your instance and let them use the instance that you were using just now. That's what unused EC2 capacity means. Okay, this one is meant for flexible or workload that are robust enough, or how to say, that does not impact, your business will not be impacted by interruptions. Okay, for example, again, as I was saying just now, if let's say you are using it for batch processing, you are taking data from a certain database and then you are migrating it into a certain database for backup, let's say. So you can go for spot instances, whereby whenever it is available, you use it. But if it's not available, it does not impact your business major. In a sense, it doesn't give you any major or minor impact at all. So that's what it means by using the unused EC2 instances. And you can get a very good discount on this. You can go up to 90% of discount rather than 70% on the reserve. You can go up to 90%. Okay. Okay. But bear in mind, if let's say during the request, there are no capacity available, you will not get any instance. That one you have to bear in mind. You will only get instances whenever there is any free allocation. When there is any unavailable capacity that's not running, then you can get that one. Okay. Okay. Other than this, there is another option, which is it's not stated here because how do you say it? This one is because it's not just for EC2, but it is for other services as well. This is what we call a dedicated host, whereby you get a rack, or you just not just get a rack. In essence, you rent a piece of hardware from AWS. Meaning you get one whole server. I'm telling AWS, I want to have one whole server just for me. Instead of having on-demand or reserve instances or whatever, I want to have one whole dedicated infrastructure for me. And the infrastructure is a EC2 infrastructure, let's say. So I want to have, because I'm not sure whether they have it, and I don't think so that we did. They can give you like the server rack and then provision it for you. But that will be the most expensive one, because they are giving you hardware as well as they are giving the internet networking and everything is dedicated for you. So that one will be the most expensive. It's a dedicated host. That one can go for, it's like, because I didn't put it here because it can go for EC2, it can go for S3, it can go for multiple other services as well. Whatever services that Amazon provides. If you say you want to have a dedicated host, they do have that one. Okay, so this one still have a long way to go. Reserve instance type, okay, we done that. Auto scaling. All right, so any particular question first regarding the pricing options of for an EC2? Okay, if not, we move on to auto scaling. Okay, in auto scaling, okay, let me just show you this one again. Instances. Okay, you have, where is it? Auto scaling, you need to have a launch template. Okay, I think I create one launch template. That's the reason why everything goes haywire just now. You can just delete the template. Confirm. Delete. Okay, deleting the template. Okay, AMIs, the images. Okay, this one is regarding when you're creating your when you're creating your instance, you can have launch instance, right? Just now, you can have this one. This is what we call the AMI, the Amazon image, Amazon machine image. You can choose this one. So here, if you look, you have this one, AMIs, you have the catalogs. So you can choose whatever it is that you wanted, the OS that you want to use. Okay, this is, there are a whole bunch of them. And then there are also AMIs that you want to, that if let's say you have your own, you want to create, and then you can just upload it here as well. And then you have marketplace whereby you have to buy. This is streaming engines, OpenVPN, so on and so forth. There's quite a number of them, like I was saying. Cisco also is there. So these are the AMIs. Okay, this one we will go into it in a bit later for storage, but do know that whenever you create an instance, here, when you create an instance, okay, let's try and stop it again. Okay, since it's running right, so yeah, it's okay. Should be still there. Okay, it's state, stop it. Okay, anyway, whenever you create an instance, it will give you one volume. Okay, because you cannot run an application without any volume. So this is whenever you create one, you get a particular volume. Okay, understand, huh? Okay, this one we will go into a bit more later on, the snapshot and as well. Okay, the networking, let's take, I want to show you the auto scaling. Here it is one. Auto scaling. Okay. First of all, we need to understand what auto scaling is. Oh, there we go. This one. I also created this one, bugger. Can I delete it or not? Last time, action. I'll just delete it first. The auto scaling, yeah. Because just now, right? Whenever you look at the instances just now, because I created one auto scaling, meaning in a sense, I need to have my instance running at all time. At least, if not mistaken, at least one instance always running. And then if more traffics are coming, the instance should replicate or should scale itself to cater that traffic. In a sense, what I did is that I was doing a horizontal scaling. I created more instances if more traffic comes in. Okay, so that's auto scaling. So, but to create an auto scaling, you need to create templates. In a sense, how do you create another instance if, let's say, you don't have a template, you don't have a base of what is it that you want to create? So there's a few steps of it. Okay, anyway, forgot about that one. I think I created during the last class, and then I forgot to remove it. Okay, anyway, as I was mentioning, the auto scaling. Okay, when we create auto scale, we have to set what is the minimum capacity that we want the instance to have, the desired capacity, as well as the maximum capacity. What it means by minimum capacity is the basic minimum of that instance, how many instances should be running at bare minimum. Okay, desired capacity, for example, you know that we look at this one, for example, if, for example, we take Lazada or Shopee, whereby they know that a lot of people are coming in, the traffic is always high. So they know that basically they will need to run 3 instances. So their desired capacity would be 3 instances. That's the normal. But during days, maybe during off-peak hours, during work hours, people don't go and browse so much. So they know that minimum, they need to have at least 1 instance. So that's the number of instances that will run bare minimum. So they can scale down to 1. If let's say that, okay, traffic is not so much, scale it down to 1. And then they know that once after office hours, after 5 o'clock, people will start going and then buying food, buying this, buying that. So they know that by after hours, they will need at least 7 instances. So that will be their maximum capacity number of instances during high demand period. So that's how you can create an auto scaling. As I mentioned, auto scaling, there's 2 types of auto scaling. It's either, they didn't say here, but I'll let you know. There are 2 types of auto scaling. Scaling, you have a horizontal scaling or you have a vertical scaling. Horizontal scaling is normally when we create more instances. We add instances. Horizontal scale, the number of instances. But horizontal scaling is you add resources to that particular instance. What I mean by you add resources is that you maybe add more computing power, you add more memory to it, so and so forth. But you don't change the number of instances. You just change the resources for that particular instance. So that's the 2 types of scaling that they have. Okay. Also, they have manual scaling in a sense. For example, you go into your AWS and then you can see, okay, instances, and then you know, okay, I want to create 1 more. So you can do that, auto scale it by yourself. Manually, you can, but they do give you the option of auto scaling in a sense, depending on the situation. They do have that. Okay. So what else is there? Okay, so this one, nothing more here. Okay, let's just go here. Okay, page down. Auto scaling approach. Okay. The approach that we have is the dynamic scaling. This is what in auto scaling they have this what I call that options for you to choose whether you want to use dynamic scaling or you want to use predictive scaling, or you can use both, a combination of both. Dynamic scaling, what it means is that they scale up or scale down your instances, the number of your instances, depending on the demand. If, for instance, the traffic is high, then they will scale up. When the number of traffic is low, then they will scale down. I'm just taking an example of web services because that's the easiest one people will see. Right? Okay. Predictive scaling is whereby you need to have your instance running, if I'm not mistaken, at minimum 24 hours, because they will need to have that metrics data of throughout the day for them to predict how how to call that, how the curve, or how um the trend of the traffic. The trend of traffic, I don't like that. I think that's the correct word to it. Okay, so with those data, they will try to predict, for instance, they know that during the morning time, there will be less traffic. The traffic is more towards evening, or in some cases, more towards the early morning before morning itself. So during those time, they will, based on the metrics, then they will scale up or scale down your application. Okay, this one, elastic load balancing. Okay, this one is after. Okay, fine. All right. So, any question first regarding the scaling?
Hello.
Hmm.
Boleh dengar ke?
Yes, Hafiz.
So the price based on the auto scaling kan. So the price will go up and down based on the skill, is it?
Yes. It is
Okay.
per instance, correct?
So it's as per what we use.
All right.
So how about the billing structure? So whether it will show the consumption of the storage or traffic, or how?
For EC2, it will build as how many instances and how long you use that particular instances. Because the bill, if let's say, if it is per hour, correct, right? If it is per hour, then you will be billed as how long. If let's say you are using on demand, we just take an example of using on demand. Okay, we just take an example of using on demand. If auto scaling is used, and then at one particular point, they use, instead of 2 instances that you are running, you auto scaling to 3 instances as an example. Okay, so you do get billed for 3 instances instead of 2. But when they scale it down, you are billed with 2 instances again. Okay, but for reserve, remember or not, we have a reserve pricing. If for reserve pricing, you already stated how many instances and for how many periods. So that one you already paid. Well, the payment itself, you don't normally pay upfront. They do have billing options for you, whether you pay a bit upfront and then monthly, or you pay after you use them, then you pay. Also ada the billing options. So that one, and they do have a calculator, a billing calculator for you to predict how much that you need to pay. That one later on, I think tomorrow or day after tomorrow. I think the last day we will look into the billing calculator. But that's how you can predict, or you can know how much that you need to pay for the services. That's why when you are using auto scaling and stuff like that, you need to use their calculator, because it will reflect that easier. Okay. Any other questions? No one? All right. If no, then we'll go straight to elastic. Macam banyaknya lagi. Dah nak pukul 1 ni. Banyak lagi ke? Okay, tak banyak dah. Okay, fine. Sorry. Risau, takut nanti kan korang lunch ni ada tertinggal. All right, so elastic load balancing. Okay, just now we've talked about how the instances is scaled up or scaled down. Okay, So, but when we scale up, right, for example, when you scale from one instances and then from one instance to 3 instances, but how do you manage the traffic? Again, I'm taking, as I mentioned before, I'm just taking web services as an example because it's easier for you to imagine it other than taking any other example. Alright, so if let's say kita tengok macam ni lah, susah kan kalau if you want to have a look at it, we just look at it at a supermarket counter. So people are coming in and then people are buying at certain time, maybe you don't have that many customers. So you only have one customer or two customers, so you only open one counter, which is one instance to cater for your customer. But comes lunchtime, a lot of people coming in. Okay, a lot of traffic. So one counter cannot cater for all of the traffic because you can see people are start queuing up. So you open up more counters. You are auto scaling. You are scaling from one instances to multiple instances. Maybe you open up 3 counters to cater for the traffic. But how do you manage the people who are queuing to which counter that you need to go? Okay, this is where elastic load balancing comes into picture. Elastic load balancing is like the guard yang dekat bila queue tu kan, not guard lah, I would say that one of the employee that when you have that queue, they will say, okay, one, you can go to this queue, one, you can go to this counter, one, you can go to this counter, this one is open, you can go here. So that is the elastic load balancing. So it will distribute the traffic to the empty or the available instances, so that one instance will not be burdened by the traffic. Okay, that's what elastic load balancing is. We do have that in the normal traditional networking. We do have our load balancer, so on and so forth. It's just that this is what AWS offers because they offer the auto scaling service, the option for auto scaling. So when you auto scale, so people will ask, how do you manage it? So this is how AWS manage the traffic when they auto scale your instances. Okay, quite easy to remember. So when there is high availability, work with auto scaling. You use it when there is high availability. You work with auto scaling because you are creating more instances. So you need something or a service to control the flow of traffic or to which point that it needs to go, to which instance. Okay, route around unhealthy instances. If let's say one of the, if for an example, you open up 5 counters, but in one of the counter, for example, one of the customer, the credit card doesn't work. So there will be a bottleneck there. So the load balancer is the one that, okay, I know that one is not working at the moment. Okay, we'll just use this for. So the load balancer or the elastic load, ELB, short form. That's another thing about AWS. AWS love short forms. Whenever you see ELB, EC2, S3, all this, they will not call it by the whole name. They will just give you the abbreviation. So do keep that in mind. The ELB, so the elastic load balancing, this is the one responsible to delegate the load of the traffic. Okay, this is happen only when you have multiple instances. If let's say you have only one instances, you don't really need to have a load balancing. Okay, all right. Okay, but again, as I mentioned, if you want to use load balancing and you want to use auto scaling can only be used if you have a template. Your instance already have a template, because if not, they don't just replicate another instance without a template. Template ni macam template is like a blueprint of how your instance is created. So you need to create that one first, and it will autoscaling will use that template to create new instances. All right. Any questions? Simple kan? Nothing so mind-boggling about this one. All right. Next one, we'll go into monolith and microservices. Anyone has ever heard about monolith? This is not something from prehistoric. Monolith is, I think last time on today's sejarah they have monolithic or something. This is not it. This is a way different thing. Okay. Okay. In early beginning of programming, most programs or most application, most systems are built on monolithic architecture. What we mean by monolithic application or architecture is that the application is tightly bound from one component to another. They are fixed in that sense. You cannot have one component down without failing everything. That's how it is. If you look at the old program before classes, before object oriented, this is like when we're talking about C programming. Nowadays, C programming already have classes, but this is predated. Something like Fortran, something like Pascal, COBOL, those old programs where they work in a sequential state, and you don't really call another program. It runs by itself. So that is what we call a monolithic structure of programming. One aspect of it goes down, everything goes down. Okay. There. It says tightly coupled components. Monolithic application is tightly coupled components. For example, you have your user management, you have your application management, all under one roof. If one of them, if let's say you have four tiang for a pondok. Okay, for a pondok you have 4 tiang, and then each component is a tiang. If one tiang breaks down, everything breaks down. That's how monolithic architecture is. Okay, whereby a single component failure can affect the entire application. The whole thing goes down. It is resilient architecture. This is why most people are moving out from monolithic architecture to microservices. Okay, this is the old, I would say the older approach to programming. Okay, microservices are the recent one whereby you have loosely coupled components. What it means by loosely coupled components is that everything if you are into programming, everything is its own classes, its own thread, I would say. If you are going from engineering background or computer science, computer engineering background, its own thread. If one thread fails, it doesn't mean that the whole application fails. It's just one of the components. Okay, so it is still able to work together, but if one of them fails, you just restart it without having the whole thing break down. An example of this is, for example, we look at how businesses, the web businesses are run presently. For example, if let's say you go for Lazada or Shopee, they cannot afford to have the application any downtime on their application because it will cost money. But with that in mind, they create the components around the application to have it loosely coupled so that it doesn't bring down the whole application down. Maybe you will not be able to log in as a merchant. You may not be able to log in at certain hour because the service is down, but you can still able to browse through the shop, something similar to that. So the user management is one component, and then you can have the payment gateway as another component. So these components do work together, but they are not dependent on each other. Something similar to that analogy. Okay, so it is more resilient architecture. What it means by more resilient is that if one component is down or one component fails, it does not affect the whole system. That's what it means. All right. So that's monolithic versus microservices. Microservices, there's a few type of microservices. You can, any of you ever heard of Docker or Kubernetes? Those are containers and stuff like that. Those are all microservices whereby you run your application not remotely, but it is run in separately compared to the rest of the components. Okay, right. So, okay, because of this, because of the multiple components, so you need to have a method of communication between those loosely coupled components. Okay, this is where another service from Amazon introduced. Okay, we have the messaging services from Amazon. The messaging services, this is to communicate between components, and mostly it's between components, or it can also be to send alerts regarding the system. Okay, as an example, here, when you create your instance and everything, I think they have one here, or they do, or is it? I can't remember. They do have this particular place, alarm, ALARM. They have the managed service. Okay, I think it's here. I can't remember where it is. Okay, anyway, what I want to say is that you can set a certain limits to your budget, because when you're running your application, you can set your application is not supposed to run more than a certain hour, or you already have one budget for the whole day, so you cannot have your application running more than a certain number of dollars per day. So when it exceeds that limits, then you want it to send you an alarm. The alarm can be via SMS, it can be via emails, it can be via messaging system, so on and so forth. So it's not just between components, it can also be outside of the component. Well, actually, you are using the components to send a message out from the system. Okay, so how Amazon catered to this need is that by using these two services, the SNS as well as the SQS. Okay. Oh no, they don't. Okay. All right. I thought they have it here, but since they don't have it here, it should be okay. SNS for we just, if I'm not mistaken, I have it here also. Okay, okay. It's okay. It is, where is it? Okay, here. Let me just go and search here. Simple notification. notification service. Okay, here. SNS, simple notification service. Okay. Did I close my AWS just now? Just a minute, let me just log in again. There. Okay. SNS, simple notification service. Okay, here. I wanted to show you this one actually, not this one, but it's okay. Okay. Okay, what simple notification service or SNS is that it is okay, can read it here. It's a highly available, durable, secure, fully managed pub and sub messaging service that enables you to decouple microservices, distributed system, event-driven serverless application. Amazon SNS provide topic for high throughput push-based many-to-many messaging. This is a very important sentence. Push-based. Okay, because this is what differentiate between SNS and SQS. Okay, one is a push-based, one is a pull-based. Okay. Okay, anyway, okay, let's go here first. Because since this one is quite it's not really that much of information. Anyway, okay, what SNS does is that before you need to use SNS, you need to create a topic for it. Let me see whether is it there or not. Okay, okay, yeah. You need to create a topic. I don't think I have any topic in my account at the moment. A topic can be anything with regards to your message. You can create multiple topics, doesn't really matter how many topics do you want, because number of topics will not be charged. What will be charged is how many messages are being sent. If I'm not mistaken, it is charged at 50 cents per 1 million messages, if I'm not mistaken. Okay, I might be wrong, but if I'm not mistaken, it is 50 cents per 1 million messages, which is a lot. Quite a lot, quite a number of it. Okay. So if let's say a certain alarm is triggered and you want it to send a message to, you want to send a message to your phone, let's say. So you can create the service when alarm is triggered, and then you can send out the message with regards to the topic. Okay, that will be one message out, and then that's how when they will count how many messages that you are using. If let's say you are sending out to multiple people, they will count how many messages that being sent to these particular people. This is very crucial. SNS is normally used for critical or very time crucial messaging, because as I said, it is a push base. Once you get triggered, then you will push. You will send out the message. Okay. So the recipient can be anything. It can be like I said, it can be a service, a messaging service. It can also be what do you call that? A web point. In a sense, okay, when something happens, you go to this particular website. You can also do that. Also, or you can also have something like if something happens and you want to trigger some application, you can use a serverless application where something that we will go into later on. Something a program where you can put in AWS, and then when something happens, you want to trigger that particular program, also can. or you can have when something triggers, you want to have it email also can. That is when I said that it is a timely critical messaging. So if something happens, then you want it to be notified immediately. Then this is the service that you need to go for. Benefits, reliable, so automatic scaling, workload, so on and so forth. Use cases, they have it on is blah blah blah. Okay, the next one is the SQS. This one is a queue services, simple queue service. How come this one is, but this one is not? I'm not logging here. Okay, let me just have it here, SQS. Because this one will not give you. They have videos. Okay, those who need to watch videos, go and have a look at it. They have SQS, and also they have SNS. Okay, let me see whether they have SNS also. Then we can just play the video, and then let me just, yeah, SNS. Is that how it enter? It's not. Oh, yeah, there. Ayo, I thought how. Oh no, no video here. Okay. So got video. You guys want to watch the video? Yes? No? You can go and watch it yourself. Okay, fine. You can watch it yourself. Okay, so if you go and have a look at SQS, you can also find this particular video here. So what SQS is that it is, okay, here, let me see whether they said it or not, and provide queue for high throughput system to system messaging. You can use queue to decouple heavyweight processes and to buffer and batch work. Amazon stores messages until microservices and serverless application process them. Okay, say here, they will store the message until the microservices and serverless application process them. What it does is that when you give SQS, or when you when something triggered and you push out the SQS, what it will do is that okay, what it will do that it will put this particular message in a queue. Okay. Oh, now I know where that noise is coming about. Okay, it's coming from the messages. Okay. So sorry. All right. Okay, so anyway, it will give and push this particular message into a queue. Okay. It will stay in that queue until whoever met for it, take it. Okay, as an example, if let's say, macam mana nak kata, as an example, let's just, okay lah, kita tengok some layman punya example. Okay, macam ni. Okay, katakan kita pergi, kita ambil yang supermarket tadi. Okay, you are queuing. Okay, you queue, and then instead of you queue and you wait for your order, you just write down. Ini macam something similar to kita pergi self-service restaurant. Not self-service lah. Not self-service whereby you go and click. Yeah, something where macam McDonald's, whereby you can just choose your order. You just choose your order, and then you push that particular order. Okay, that particular order will go to the kitchen. Kan? Okay, so that's how SQS work. You create a message, then the order, and then you push it to the system. And then you just go and do whatever it is that you want to do. Shopping ke apa ke, until that particular order is done. Okay, so when the kitchen receives the order can be for drinks only. It can be for food and drinks, and it can be for food only. So if it is for drinks only, it is up to the let's say lah kita pergi McDonald and then dia ada apa tu yang McCafe tu. Okay, so only the barista will go and pick up that queue. If that kitchen comes to the messaging board and look at it, oh, this is a barista punya, it's McCafe punya. Oh, ada orang angkat tangan ke? This is a barista punya message, so it will not take. Dia akan pergi balik. Barista datang, okay, this is for me, I will take it. For example, the barista datang and then look at it. Oh, this is something that I don't know how to do. Then dia keluar. Dia tak akan ambil. But someone else, another barista may come and okay, this is, I can take this particular order. So this is what it means by it will store that ticket or that order, that message until whoever it is supposed to take it, process them. Either it is a microservice or either it is a serverless application. Takes that particular message and process it. If, for instance, macam tadi kan, the example that I gave you, a barista comes up, it is who it is intended to take that particular message, but oh, I can't do this, or some error comes about, and then it will release back that particular message to the board. So it will still be on the board until someone process them completely and then okay, fine, done. Okay, there is a shelf life for the message. If I'm not mistaken, how long was it? 7 days or something. I'll have a look and then I'll let you know again. But there is a shelf life for it. There is a certain hour limit before it is discarded. I think I have it somewhere here. Let me just have a look again. Sorry about that. Let me just have a look. Okay. Okay, here it is. Oh yeah, correct. Okay, it is correct. The pricing just now, it is 50 cents per million requests. Okay. Okay, there is here. SNS pricing 50 cents per million requests. Okay. SQS also, SQS is cheaper, is 40 cents per million requests. Okay. Okay. And then where is the live shelf for it? Let me see. Quite a number of things that need to be read. Okay. So like I said, for things like this, right, whereby not a lot of information, you can just write down if for additional informations. Okay. Somewhere, can't find it again. I know I have it here. Okay, I'll get back to you on that one. The shelf life, there is a shelf life for it until it is being discarded. But as I said, the message, but this one is polling, meaning the person or the microservices that needs to handle that particular message have to go to SQS and see what messages that they have and are there any messages for them to process. Okay, so that's the difference between SNS and SQS. SNS, if it is a critical, timely critical, then you need to, it's better for you to use SNS. But if let's say it is a batch work or something that is not really that critical, you can have SQS. Another example for SQS you can use is that if let's say you have a process that is being done and then you need to wait for it to complete first, only then you can process a new one, then you can go for SQS. Okay. All right. So okay, so this one is, do I have it here? Here also no. Okay, tak apalah. Okay, anyway, we don't have it there. Okay, another thing is that I mentioned to you just now, not I mentioned here, it mentions here regarding this serverless application. Okay, so I think this is what we'll be going into next. Yes, serverless computing. Okay, what does it mean by serverless computing? Does it mean that there is no server at all? Then if there's no server, where is the application working at? Where is it coming from? Okay, the term serverless computing in AWS is that you don't need to commission the server. Okay, okay. Okay, there is a terms whereby where we call it infrastructure as code or infrastructure as function. Okay, that's that one where you can Google it up. I think I have that particular. Let me see. I think I have it. Let me just have a look. No, not this one. This one. Let me just have a look. I think I have that particular. Oh no. I think I have that particular slide with me, and I'll just share it with you. Let me see. Just give me a minute. Classroom. Yes, I do have it. Let me just publish it for you. Okay, so yes. Okay, this is something that I was talking about. Okay. Okay, you will have traditional on-premise, which is you have your application, you have your hardware, you have your virtualization, OS, and everything. These are all managed by you. You have infrastructure as service or IaaS, where the data configuration, the application code, the scaling, the runtime, the OS are run by you. But the virtualization and the hardware is not run by you. In a sense, it's not managed by you. Some other provider will manage it for you. Okay. Example of infrastructure as a service would be something like EC2. The virtualization, the hardware, you don't manage it at all, but you do set what is the OS, how the scaling should be, what the application should run on it, and the data and the configuration. This is something as infrastructure as a service. Okay, and then you also have container as a service. This is more like for containerization. This is for microservices. Platform as a service. Okay, data configuration, application code, and scaling is managed by you, but the runtime, the OS, the virtualization, the hardware, everything else is not run by you. These are all by the provider. An example of this would be like something like later we'll see. This is something like the serverless. The serverless, because you don't handle any of this, but you will handle the application code. This is something that is the serverless. This is what I mean by you don't commission. Even the OS itself, you don't commission. You don't tell them what OS you need. That one, they will handle. What you will need to do is you just give them the code that you need to run. So this is something for serverless. So it's not really there is no physical server running the application. It's just that you don't commission or you don't really configure the server itself. You just say that, okay, I want this particular application or this particular program to be run, and then whatever it is that needs to do, you do it. I just know that this particular application needs to run. That's about it. So this is what we meant by serverless. It's not as to say per se wordly, it is no server at all. Okay, they also have this, which is function as a service. Everything else, you just give them the application. This is a part of platform as a service and software as a service. You just give the data configuration as well. Okay, so this is something that you will see quite frequent when you are talking about when we go into the essence of cloud computing. You need to know in which area or in which category it is residing in at. All right, so that's about it. Okay, so that let's go for serverless computing. Okay, serverless computing meaning there is no provisioning or maintenance at all that you need to do. As mentioned just now, you don't provision, you don't tell them what server, what processor, how many RAM, how much memory it requires to run your application. What you need to do is that you just give your application. Okay, so that's one of it. How the scaling and everything, all of it will be handled by the provider, by AWS, and you pay per use. Every time your application is initiated, or if every time it is run, then you pay for it. Okay, for example, this is an example. If, for example, if you have a situation whereby you set a trigger, like just now, you set a trigger, SNS, let's say. If you hit an error, give out the SNS, give out the error, and this particular SNS need to send a message to a Lambda, which is one of the serverless application services that is provided by AWS. And in this particular Lambda is, I'm not sure whether you are familiar with it or not. Lambda is actually a programming term where you use basically when you have a signal and slot. You have something happen, a signal, and then the slot is the application that you run. Okay, so signal and slot is basically what a Lambda is. So it can be any programming language. Okay, let me just see whether I can get into that or not. Lambda. Okay. Lambda. Here. Okay. In this, okay, I do have a function. All right, fine. Okay, this is a function that is created by in a Python language. Okay, let's just go inside. Okay, in this particular example, we have, I didn't put any trigger here. So you do need to have a trigger. Like I said, it's either SNS, SQS, so on and so forth. But Lambda normally we use a SNS because it is a timely. When you send it, then you want it to run. Okay, in this particular example, I just have it done Lambda handle hello world, just hello, whoever it is. And then in the test, I think I put one, okay, I put one JSON data there. So if I test, it should come out as hello Rosnan. Okay, so I said it, the name is hello world, hello Rosnan. So instead of hello name, it put the name from the JSON just now. So another way, this is just a simple example, but of course, a more real life application should be when you receive a signal, when you receive something like in the JSON format, let's say. The JSON format can be something similar to this. Let me just show you. Kubernetes. Okay, let me show you this one. Kubernetes. Kubernetes have quite a number of. It's not really a JSON format. It is more of a XML format, but it is something similar because you can convert it into a JSON. Kubernetes documentations. Let's just go to documentation and let's create pod, let's say. Okay, pods. Okay, for example, here, this is a YAML file for this is running on Kubernetes, which is something that you do have in AWS as well for containerization. If, for example, in the YAML, in the SQL, you are sending something similar to this. You want to create a container with the name of Nginx and using the image of Nginx 1.14.2. So you can send something similar to this in a JSON format, because this one also can be in JSON format. You can send it to the Lambda for it to create a pod or another container or another process, so on and so forth. It depends on whatever it is that you need to do. Instead of having a whole EC2, you can just create a simple program for it to do the task it needs to do. Here you will pay less instead of having instead of paying for a whole server, you are paying only whenever your function is being called. Okay, so that's Lambda. It's a serverless application. It's serverless computing, where you don't need to provision anything. You don't need to maintain it as well. Scaling also, you don't need to maintain. Everything is handled by the provider, by AWS. Okay, so this AWS Lambda is a type, is a service, a serverless service provided by AWS. What you need to do is upload your code, like I showed you just now. Very simple code, also can. Just upload it. And then you have to set a trigger. You have to set a trigger, how it is, what makes it run. Okay. And then set a trigger and then run when needed. And then you pay only when it is run, when it is used. And you don't pay like per hour, stuff like that. So it is cheaper. Okay, this one, the same as just now, not the same. This is also a serverless service container. This is a part of microservice because we are talking about microservices. Okay, in microservices, this is how to communicate between the microservices, and this is how we do microservices. Okay, microservices can be in terms of container service. This is AWS ECS, and you can have Kubernetes, something similar that I showed you just now. This one, the Kubernetes. Okay, AWS also have something for Kubernetes inside AWS, and you have the Fargate. This Fargate is used to control or to orchestrate the containers. See, it's a serverless compute for containers. If you have containers, then you use this. If you have Kubernetes already, then you don't really need to have Fargate. But if you want, you can. But normally people don't use it anymore. Use Fargate as well. But these are just to tell you the services that AWS provides for serverless. In that sense, you are using containers for microservices. Okay, Then module summary. Yes. All right. So we have 4 minutes. I think we should have enough, not to do the quiz, but to go through the summary itself. Okay. So we learned about EC2, which is the compute power for AWS, and then how we can use EC2 to optimize our infrastructure in terms of scaling, in terms of provisioning. We can create instances not instantly, but in less time. It optimizes our infrastructure, whereby we have our load balancing there. Okay, correct. We have auto scaling. We have load balancing to optimize whenever heavy traffic are there, and then we look into SNS and SQS to communicate between the microservices or between the services that we have, as well as we do look into the Lambda functions and the container services. You don't really need to know a lot about container services because containerization is a whole domain by itself, because like EC2, you can create instances in every container. Okay, if you have more questions about it, we can, I'll try and answer it after the break, after 1 o'clock, if you want to look into containers. But as for this particular exam, for CCP, for cloud practitioner, you don't need to do any coding. You don't need to do any practical. The only reason why I'm showing you some of this is that to give you a better idea of how, when we say that, oh, you have to provision a trigger, you have to provision when you provision your EC2, what is the family, so on and so forth. So you have an idea what it is. And that's the only reason why I'm showing you this one. It's not for you to go and create, but it is advisable for you to go and create your own account and play around with it. It's good. I'm not saying that it's not good. Go ahead and do that. But that's the only reason. Okay, any particular question? We have 2 minutes before our lunch break.
For the Lambda functions,
Yes.
right? Is it possible for us to use the SNS alarms to, for example, like,
Yes.
is it possible to
Yes.
like turn it off? Oh,
To turn it on, to trigger it.
yeah, you can use that as a
Yes.
trigger as well, lah.
Yes,
I
correct. Yes,
see.
you can.
Okay. Okay, that's cool.
That's that. As I was saying just now, you can use, for example, if there is a alarm, or in a sense there is a message, not message alarm. There is an alarm saying that you don't have auto scaling. Let's say you don't have auto scaling. Okay, you don't have auto scaling, and then when something hits, if let's say the processor hits a certain limit, you want it to send you a message. Okay, you can have SNS doing to send you a message, but instead of going to your phone or to anywhere, you can have it send it to a function, whereby in this particular function, you have your API to create an instance. Get it? You can have that.
All right, I understand. Yep.
It can
thank
be
you.
anything. It can be create an instance. It can be creating a new block storage. It can be a new memory, so on and so forth. Okay. Any other last question? Because it's 1 o'clock. Any last question? Okay. If there is no question, we'll break for lunch, and then I'll see you guys in 1 hour. We start back at 2 o'clock. Okay. All right. See you then.
Should we
Thank you
leave
so
or
much for listening. You can just stay.
okay,
It doesn't really matter.
thank you.
Internet dah kena charge dah pun. Tak kira. Tak kisah. Okay, right. See you.